Hello, this video is going to be about Chapter 10. And Chapter 10 in your book begins on page 65. And this is the quiz for Chapter 10, or Unit 10 rather. I know I call it one thing and the book calls it another, and I do apologize for that. So the chapter, if I say chapter unit, it's all the same thing. So let's begin by looking at some of the things that the chapter unit talks about, and beginning with the 3-4-5 method. So 3-4-5 means that when we try to square a corner up on a house, and we use the batter boards, and you can see that on figure 10.4 of page 66. So we need to establish the corners of a particular house. Let's say if this house is in this shape here, then we want to establish each one of these corners here. And we can do that very easily by 3-4-5. Now wait a minute, he's saying 3-4-5, this says 6, 8, 10. Well, yes, it can be any unit of 3-4-5. So we could say 3 times 8, and we have 24. 4 times 8 is 32. And if we say 5 times 8, what do you think that's going to be? Well, it's not going to be 8. 5, let's try this again. 5 times 8. So we have 40. So we would be using 24, 32, 40. Meaning that if we measure out from this corner, in this particular case, 6 units, we measure up 8 units, the measurement, or the measurement between those two marks, is going to be 10. So we use 3-4-5. We say it is 3-4-5, but in this case, we took 3 and multiplied it by 2, 4 multiplied it by 2, and 5 and multiplied it by 2. So that's how we end up with that. So if we take that triangle of 3-4-5, then we can manipulate it to any size that we need in order to do our project. So if we're looking at our house plan here, let's talk about the garage here for just a second. So we have a garage that is 13.9. So how could we do that to get, as much as we can around here? So if we take and say 3 times what? 3 times 3, that's 9. What about 3 times 4? Ooh, now we got something. So now we have 12. So we could start right here in this corner, and we could measure out, excuse me, we could measure out 12 feet out here, and we can make us a mark. As a matter of fact, let's do that right quick. Print screen. Let's go over here to this, and voila. We have our little drawing here that I can make some marks on. Maybe if I can get it to be still. How about just use the slider bar? So we can measure over 12 feet. And we're going to be, I don't know, somewhere right in there. Okay. Now we said that was 3 times what? It's 3 times 4. 3 times 4 equals 12. So now we go 3, 4, 5. Remember how that triangle works. We're going to say 4 times 4 is 16. And now listen to this. Of all things, JJ's going to call me in here. I'll call him right back. We can all make fun of JJ later. Okay, so I'm going to say 4 times 4. Bam, 16. So now over here, I'm going to measure down 16 feet. Well, look at there. It's already there for me. 8, 16. So I'm going to make me a little line right here. Bless his heart. And I'm going to have 16 feet down here. So I've got 12 feet over here, and I got 16 feet here. Now, we said that we multiplied everything by 4. So 3 times 4, we got 12. That's here. 4 times 4 is 16, so that goes here. What's our other one? We said it was 3, 4, and 5, right? So 5 times 4, and that gives us 20. So if we were to pull a measuring tape from here to there, this line, if this is perfectly square right here, right angle, then this is going to be 20 feet. If it's not, then we're going to move this point or this point. Generally, we establish a point. So we might establish this line across through here. And then we're going to establish this line down through here. But maybe we need to move it back and forth so that we get it perfectly square. Bam, drop that booger. And then we can line this up through here. And this should be perfectly 20. So 20 on this one. This line over here to this point right there is 12. And then this point right here, if you'll remember, was 16. Okay, so these are still all the 3, 4, 5 method. This is 3 times 4, 4 times 4, 5 times 4. And we were able to work it out and get it squared. Okay, so anytime that we have a right angle, anytime that these are perfectly square at 90 degrees, all of them, then we can figure out that this and this measurement here are going to be perfectly equal. So how can we figure that? So let's go to our construction calculator here for just a second. So I have my construction calculator, and I'm going to stop over here just for a minute and pull this out so that I can see it, where it doesn't give me any in between, does it? Okay, I can see those two. Okay, so I have 13 feet 9 inches, and I'm going to put that as the run because it is going in the X, so that is the run. And then I have 24 feet, and I'm going to call that the rise. Okay, so I have a rise of 24, which is here. I have a run of 13.9, which is here. So what do you think this is going to be? Well, let's find out right there. This button right here, diagonal. We're going to hit diagonal, and we're going to know that it is 27 feet 7 and 15/16 from this corner to that corner, and the same thing from this corner to that corner. And that way we know that this is perfectly square. Okay, so let's go back over to here. All right, that talked about the triangle. And here again, it doesn't matter what size our rectangles are. Anytime that we have all of our corners here at a perfectly 90-degree angle, then our diagonals are going to be equal. So let's talk about footings for just a minute. Footings, and this is a spread footing, and we're basically taking the weight of the building here and we're spreading it out across more ground here. So we're taking what we have here, and if this is 8 inches, let's say that it's 8 inches here, and we have 100 pounds on it, so we have 100 divided by 8. So 100 divided by 8 is 12.5 PSI, okay, per square inch. So even though this is not a square that we're talking about here, we're just talking about linears. If we take our poundage and we divide it by our square inches in here, in this case we're going from 12.5. Now, let's say that, for instance, this is 2 feet. Okay, so we're taking 100 pounds that we had here, which was a PSI of 12.5, and we're going to say 100 divided by, remember what we said here, 24. Look at that, 4.1666667. Now, what does that mean? That means that we have pulled down the PSI here so that our building doesn't sink. What if our ground right here only had a PSI of 10, for say? So we have 100 pounds coming down on this, and we have 8 inches here. We'll say 8 square inches, okay? And then down here we have 24 square inches. So at this point, we said that we had at 8 square inches, and we'll put in here square inches, we ended up with 100 divided by 8 equaled 12.5. I think it was. Let's see if I still got that in there. No, I don't have it still in there. 100 divided by 8 equals 12.5. Okay, good. I remembered that. Okay, so now we're going to come down here, and I'll put in SI here. We have 24 square inches equals 100 divided by 24 equals 4.16667. And that is PSI. All right, pounds per square inch. I'll go back up here and put PSI here as well. PSI. Okay, so remember I said, what if our ground is only worth 10 PSI? All right, so that means that if we were going with this, this is greater than that, and this would sink. But because this is only 4.16667, then it is less than the 10 PSI that the ground will hold, and that way it does not sink. I hope that clears that up a little bit. If not, let me know, send me a text, or ask me in class, and I would be glad to try to explain it to you in a different way. Now, when we're looking at our footings, so in this particular case, we have a footing that is shown by the dotted line that's going all the way around. And we can go to the elevations and see somewhat of this footing. Now, you'll see that, well, something funky is going on here. All right, so this is the front of the garage. This is the side of the garage. And what the heck is going on here? Why do we have this going here? Well, this is called a stepped footing. And when we look at that, this is how a stepped footing works. And a stepped footing means that we can step it down and allow the masonry. If we don't have a basement or nothing under here, we can just let this flow with the land. You see how the land goes here. We can just make this, let this flow. So what is our maximum and minimums on this? So in this particular case, the code tells us that any flat, and it's from here to there, any flat must be greater than 48 inches. Now, why is that? I mean, it can be 100 feet. It can be 300 feet. It just can't be 2 feet. It has to be 4 feet or 48 inches. The code also tells us that from here to there, this vertical movement here can only be less than, okay, so remember we're greater than 48 here. This is going to be less than, what do you think it is? Let's try 24 inches. All right. So it is, you cannot step a footing any greater than 24 4 inches. Okay, a minimum of 48 inches on the level, and the maximum that you can do is 24 inches this way. Now, why is that? A block. How big is a block? A block is 8 inches high. One single block is 8 inches. And even though we have 16, all right, so we have a block and a head joint is 16 inches, then we have a bed joint and a block being 8 inches. We can also cut this in half. What? Yes, because we can split these blocks. We actually have half blocks. Our blocks are now 8 by 8. So by doing that, does 48 divide by 8 equally? Sure it does. 48 inches divided by 8 inches equals, we have 6 half blocks in there. All right. And if we're going high, 24 inches divided by 8 inches, we're going to have 3. Okay. Again, 48 inches divided by 8 equals 6 half blocks. 6 half blocks. So if we got full blocks, how big is it? Full blocks would be 3. And then if we have 24-inch high maximum divided by 8 inches, we end up with 3 there as well. So 3 block high, 3 block long, and there sets our standard. So let's see if I can do this. So there's 1, 2, 3. All right, so that's 3 block that we can go there. Now this only says that we're only going up 8 inches, but we can go 1, 2, 3. So if we wanted to, we really could pull this footing all the way up to this point here. We could, if we can draw it, we could pull it all the way up to that high because we have 3 block. Boom, boom, boom. 3 block this way. Boom, boom, boom. Now this is the maximum. This is the minimum. Okay, we can go 100 block, but we have to go at least 3. Okay, so when we're looking on our plans now, we're starting to see something odd. It's starting to ask us all kinds of stupid little questions like, well, what are these heights? They don't make any sense. So let's look at that for a second. Let's go over here to our site, and we're looking at the elevations. And we have an elevation marking here, top of masonry at 343.33. .33, and that is feet. All right. And if we want to find out what this elevation here is, we're going to subtract 4 feet, 4 inches. Boom. So this, in a sense, really is going to be 339. Okay, we'll round up. 339. Now remember what I've told you, and I just did it myself over and over and over. Let's try this again. I'm going to clear this out. Always carry those numbers out as far as they'll go. Okay, that is as far as this calculator is going to let me carry those 3. Anytime you see 0.33, that's a third, and it goes on and on and on and on. Don't believe me? 1 divided by 3 equals, not that number. 1 divided by 3 equals, see how they just keep going and keep going. This computer knows that it keeps going. So when I punch that in, I want to make sure that I put the maximum in there. Okay, so that is feet. And now I'm going to subtract 4 feet, 4 inches from that. Notice how it rounded off perfect this time because the computer knew that I was going indefinitely with the 3s. Okay, so now the elevation at this point right here is 339. Well, what is the elevation at the bottom of the footing? Well, we want to subtract another 8 inches. and by doing so, we end up with 338.33 down there. Now, what is that? Well, if we go in and we hit our little convert feet, it changes it over here to 334 feet and 4 inches. Okay? Does that make sense? I hope so. So let's look at one other thing right quick before we get too far. One of the questions asks, what is the deepest footing that we have? All right. So is it this one? Well, maybe. What about this one down here? Well, it's possible. Let's do the old print screen here, and let's go over to our paint and hit Control V, and I can start playing with these lines again. So I'm going to just hit on that, and I'm going to pull it out perfectly straight. And I can tell it's perfectly straight when I don't see any juts in it. All right, so there's perfectly straight. So obviously this one right here, can't do that circle very well. This one right here is going to be much, much deeper than this one over here on this side. But what about down here? Let's see, don't do that, go back to here. I can't, yes I can roll down. No I can't, that's as far as it goes. So that's interesting. All right, let's go back over here, and I'm going to roll back up. I'm going to hit print screen again, go back to this, and hit, there we go. So now I've got another one here. So if we puncture in here and go all the way out to here, straight, we see that this one and this one are both equal. All right, so what is our distance here? Well, we don't know, do we? So right here, it tells us that the basement, let's see if I can pull that in. I may have to, let me go back over to this one here. Our basement floor top of masonry is 337. Okay. Now what is this? Well, we don't know, but if we go right over here, this top of basement, or excuse me, basement floor, top of masonry, finished floor, and top of masonry is the same thing. You don't believe me? We'll come back over here and we'll do another line, and we'll go right from here, right across through here at dead level. Bam. Look at there. Same line. So if this and this are the same, then we can obviously go back over to our little handy dandy computer calculator here, and we can say, well, we've got 337 feet. All right, and we're going to subtract 5'4", excuse me. Let's try this again. Click there. 337 feet. Subtract 5 feet 4 inches. So it's going to be 331 and 8. But what if it's a decimal? Well, that's okay. We'll just hit feet, change it over to a decimal. 331.667 at where the top of my fingers here are, not my hand, but the top of my fingers, where I'm grabbing that line right there. Okay, so, and I want to go on and I want to find out what the bottom of it is. So I'm going to subtract another 10 inches off of that. And now I have 330.8333333. Now, can anybody tell me what that is? It's 10 inches. Now, how do I know that? Because the computer says it's 10 inches. One thing that I want you to try to learn is I want you to learn these decimals by heart. So when you see a point 8888888 or a 0.1666667, you know what these are. So I want you to write these down as I write them down for you. As soon as this word comes up, we'll do that. While I'm doing that, I'm going to check on JJ and see what he needed. Love you, JJ. I know you're hearing me. Just want to ask you a couple of questions. Yes, sir. Well, I'll get to you in just a second, son. Okay. All right. So things that, you know, the inches you need to know. So we have 1 inch. That is equal to 0.0833333 feet. Okay, that's the decimal in feet. The second one, 2 inches, is equal to 0.166667 feet. 3 inches is equal to, guess what it is? 3, 6, 9, 12. All right, so I did that 4 times, 3, 6, 9, 12, so it's 0.25 feet. All right, 3 inches is equal to 0.25 feet. 4 inches is, anybody guess? I got to think about this for a second. How many times does 4 go into 12? It goes in 3 times. Oop, we just said, remember, we're going to continue that as far as we can. Feet, 0.3333 feet. 5 inches equals 0.416667. Wait a minute. I've seen that number before. Look at there. That number's right here. All right. Wow, look at that. If I add 0.16667 to 0.333333, I get 0.41666667. Okay. Now we're going to continue on. 6 inches. You guys know what this is. 6 inches is half of 12.5 feet. All right. 7 inches is going to be 0.583333, I think. This one always gets me stumped. Let's check it out. Let's go over here to the calculator. And let's say 7 divided by 12. Did I get it right? I did get it right. Look at that. Woohoo! All right, so there's that. 8 inches. Well, now we said that 4 is 1/3. So is 8 2/3? You better believe it. Okay. 9. Well, if 3 is 0.25 and 6 inches is 0.5, what do you think 9 is? You got it. 0.75 feet. Absolutely. Great. You guys are doing good. 10 inches. Now, I want to look at something here. 10 inches. Look at 1. See where that 0 is? That 0 is on this side of the equal sign and on this side of the decimal point. Well, let's just move it over. Bam, we did. There it is. It's on this side now. So what do you think that is? There you go. There's what it is now. So remember that the 1 inch and the 10 inch are very, very similar. Okay. The 2 inch and the 5 inch are very, very similar. Okay. So continuing on, 11 inches is equal to 0.91. What's the next one? You got it right. 66667. Don't believe me? Go over here and say 9. Excuse me, not 9. Clear. 11 divided by 12 equals. Look at there. Is that right? That's right. Okay. So there's little ways, and okay, come on. Really? Really? Yes, exactly. Okay, that's right. All right, so I want you to memorize these. You need to know these. So write those down, look at them. When you're playing with your calculator, when you see that, you should know, oh, that's 11 inches. All right, so try to get into that habit of doing that. That makes it a lot easier when you're trying to read these plans, because if you don't have this calculator and all you have is this calculator, then you can easily put this stuff into your calculator and spend less time trying to figure it out and more time getting on with your work. Now, the last thing, one of the questions says, I want you to, well, I want this roll out. There we go. I want you to tell me how big is the basement. All right. So this is a funky site here, funky little shape here. But if you look in the book, it tells you to break it up into this fashion here and figure out how much you got for this area, figure out how much you got for this, figure out how much you got for this area, figure out how much you got this area and this area, and so forth and so forth and so forth. So how can you do that? Again, like here, we're going to, dang it, why do I do that? Home, I hit print screen before I push the little button here. So print screen, and I'm going to go back over here, and I'm going to place it right in here. And just to get rid of some of this other mess, I'm just going to do this number and crop it out. I can go back over here and pull in and read these different things, but what I can do here is I can separate these all just like the little picture is on the computer, and I can figure these out exactly the same way. And then, of course, I just have to draw me a little triangle right here. And I have that. And basically, I'm going to take this, and I'm going to multiply it by this to get this area. I'm going to take whatever this line is, which I think this one here, if you look up here, it is the same as this 13.9 down here. It's 4 inches off of that, yes. So 13.9 and 28.3 is going to give you this whole big thing here. All right. So what's going to happen here is you're going to have to figure this out. You just took off some. All right. So you've got a measurement here of 13.10. Excuse me. You have a measurement here of 14.2, and that's to the outside. But then we've got some space here to this center line. So we got to figure out what that is. So 14.1 less 10.3, and that goes to that center line. But now remember up here, we went 4 inches to this side of the center line. So we're going to have to add a little bit to that, 4 inches to that, figure out what this is. We got 16.9 over here to the center line. We got 4 inches there. So 16.9, put on your thinking caps now. 9, take away 4, you got it, it's 5. 16 feet, 5 inches from the outside to outside. And then I'm going to let you figure this up here. 19.2, or excuse me, 14.1, take away 10.3, and then make sure you put that 4 inches back up here for this out here, and then figure out what this here is, multiply that. Now this is a triangle, and you can use that handy dandy calculator again with rise and run, and we can say that it says that it's 3 foot 6 inches rise, okay, because that's rising. What is this measurement here? If we go down here, it's another 3 foot 6 inch run because it's on the horizontal, all right, and we're going to find our diagonal. Now, do we need a diagonal? Of course we don't need a diagonal. It's a triangle. So we can say 3/6 times 3/6, right? 3 feet 6 inches times 3 feet 6 inches. All right. But that gave us a square, did it not? That gave us this big square. So how do we get to that triangle? Easy. Divided by 2. All right. So I gave you that. There's your square footage for that little triangle right there. So that should help you with that. All right. Again, if anybody has any questions about anything, any of the questions in the book, if you see something on the plan that looks funky, you just don't understand it, send me a text. Okay? Don't email me. Send me a text, and I will be able to answer your question more on a better, more faster rate. And I'm a loss for words. It's late at night, and I'm tired. And this will be the last video for right now. So this was chapter unit 10. Okay, y'all. Have a good night.